This video is looking at end behavior at discontinuities, so at holes and vertical asymptotes. So this is a problem, an example, and I have already factored the top and the bottom. And then remember, you want to see whatever would make the denominator equal to 0. So those are your domain restrictions, and they also will end up to be your discontinuities. So that's what I was doing here to figure out what makes the denominator 0, set them both equal to 0, and solve for x. Now, these are both discontinuities. I need to decide what kind of discontinuities they are. Remember, holes are the factors that you one out, or remember, slash hole. So if you slash out factors, that's your hole. So x equals -2 is my hole. And then whatever is left, if you still have a factor in the denominator, that's going to be your vertical asymptote. All right, so to look at behavior at both of these discontinuities, and remember, a hole is called a removable discontinuity, and a vertical asymptote is non-removable. And I like to think about it, the way it's removable is I just removed it right there. So first let's look at what happens as x approaches the hole. Really what you're doing is you're just taking this x value where you know the hole is and substituting into your simplified function. So if you think these divided to get me 1, this is what my simplified function looks like. So I just want to plug -2 into the simplified function. So I just have -2 minus 6, so replace x here and here with -2, and -2 plus 4. So that would be -8 over 2, which would be -4. So as x approaches my hole, and remember it's going to be the same from the left side and the right side, so you don't really have to do left side and right side. You can just say as x approaches my hole, my function is going to approach -4. So again, behavior at a hole, just take your x value and plug it into your simplified function. Now that you've eliminated the hole, you can substitute it in and you don't get a 0 in the denominator. To find out what's happening at your vertical asymptote, I'm just going to do a quick sketch here. I have a vertical asymptote at -4. So I want to look at what happens as I approach -4 from the right and -4 from the left. So just pick these two x values to the right and to the left. So I'm going to pick -3 and -5. And all I need to check is when I substitute those into my function, do I get a positive number or a negative number? So what I want to find is f of -5, what that equals, and f of -3, what that equals. So for this, make sure you go back to your original function. And I'm going to substitute -5 in here, 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 and here. So it's going to look like this. I hope I left myself enough room here. -5 squared minus 4 times -5 minus 12 all over -5 squared plus 6 times -5 plus 8. And when you simplify that, you get 33 over 3, but really all you need to know is you get a positive number. So this means as I'm approaching the vertical asymptote from the left, my graph will shoot up to positive infinity. Then you want to do the same thing for approaching it from the right. So again, you're going to your original function and substituting -3 in wherever there's an x. When you do that and simplify this one, you get 9 over -1, so you get a negative value. So that means as I approach from the left, I'm shooting down. So as x approaches -4 from the left, that was when I substituted in -5, I got a positive number, so f of x approaches infinity. When x approaches -4 from the right, I got a negative number, so f of x approaches negative infinity.